Hello, it's Changster again. Welcome to my video on evaluating radicals. Before we get to the main part, let's go over what radicals are. A radical expression looks like this. So this is called the A root of B. It is made up of three parts, where A is called the index of the root, and the symbol here is the radical symbol, and B is what we call the radicand. Radicals with square root of 2 are called square roots, and radicals with index of 3 are called cube roots. And for square roots, we don't have to put any number as the index. When you see a radical without any number, you will know that that is a square root. We will now go over the definition of a square root. If a squared is equals to b, then a is the square root of b. This is because if you look at an example here, for example, 7 squared is 7 times 7, that gives you 49. And if you have negative 7 squared, will be negative 7 times negative 7 equals to 49. So 49 has two square roots, namely negative 7 and 7. The negative square root of 49 is equals to negative 7, and the positive square root of 49 is 7. Every positive real number will have two square roots, the positive square root and the negative square root, with the exception of 0. And because 0 has only one square root. Now we will get into the very important part on writing the principal square root or the positive square root. When we write the square root of 49, we are only looking at the positive square root of 49, and the answer is 7. So it is a little bit confusing because 49 has two square roots, but when we write it as square root of 49 in this form, we are only looking at the positive square root. So if you write it as, say, square root of 49 gives you positive or negative 7, that is incorrect because we are only looking at the principal or the positive square root of 49. Do make sure that you remember this. Now we get to how you can simplify a radical. Think about radicals as the inverse operation of the index. So for example, if I have 1 square is 1 times 1 is 1, 2 square is 2 times 2 is 4, and 3 square is 9, 4 square is 16. If you have learned a lesson about exponents, you will know that the numbers 1, 2, 3, and 4 are what we call the base number. And in order for us to get from the square number, the numbers on the right here, they are the square numbers, to the base number, you will have to perform the square root. So this is what you're going to do. So square root of 1 will now give you 1. So square root of 4 is equals to 2. Square root of 9 is equals to 3. Square root of 16 is equals to 4. You can think about a square root as the inverse operation of a square, and that's how you get the base number from taking the square root of the square number. Now let's look at what happens when you take the numbers to the third power. Is equals to 1, 2 to the third is equals to 8, 3 to the third is equals to 27, 4 to the third is equals to 64. Again, if you want to obtain the base number 1, 2, 3, and 4, you would have to apply the inverse operation of taking the number to the third, so which is taking the cube root. So you can see I'm putting an index of 3 here, and I'm going to put a 1 into this number here. All right, and this would give me 1. And if I take the cube root of 8, that will give me 2. Cube root of 27, that will give me 3. And cube root of 64, that will give me 4. What we have seen so far are very small numbers that you can simplify very quickly and easily. And I'm going to give you some examples of how we can simplify the big numbers and how we can apply some rules to make things easier for us. Let's look at square root of 100. 100 is equals to 10 squared. So square root of 100 would give you 10. And let's think about the factors of 100. 100 can be written as, I'm looking at two perfect squares, so maybe 4 and 25, that gives me 100. And let's say if I decide to break it up to square root of 4 multiplied by square root of 25. And we know that square root of 4 gives me 2, and square root of 25 gives me 5, and 2 times 5 gives me 10. And you can see that, hey, it actually is the same answer as just taking the square root of 100. So this gives us the property that we're gonna use very often, and it is the product property of square roots. For any non-negative real numbers a and b, square root of a times b is equal to the square root of a times square root of b. Radicand ab can now be broken into the square root of a times square root of b. Let's look at another example looking at a quotient. For example, if we have the square root of 100 divided by 25, we know that the radicand can be simplified to square root of 4, and that gives us a 2. And if you were to, say, break it up into square root of 100 divided by the square root of 25, and square root of 100 is equal to 10, and square root of 25 is equal to 5, and that gives us 2. So very conveniently, we can apply this property to help us simplify radicals. This property is also known as the quotient property of square roots. For any non-negative real number a and any positive real number b, square root of a divided by b is equal to square root of a divided by square root of b. If the radicand is a quotient, you can break it up into the square root of the numerator divided by the square root of the denominator, provided that b is not equal to 0. We now have a better idea of how radicals work and a better understanding of the concepts. So let's go through some examples and try them out. You may want to copy down these examples and think about how you can simplify them before checking the solution that I'm going to go over. So the first example, we have square root of 225. If we know that 225 can be divided by 5. So 225, if you divide it by 5, you end up with 45. And if you divide 45 by 5, you end up with 9. So 225 can be written as the product of 9 times 25. And we can now apply the product property of square roots to break it up into square root of 9 times square root of 25. And that would give me 3 times 5, and the answer is 15. For example B, you could see that there's a negative symbol here. It means that this is a negative square root of 36 divided by 122. In this case, we can apply the quotient property of square roots to help us simplify this radical. So we can have square root of 36 divided by square root of 121, and that would give us negative square root of 36 is 6, and square root of 121 is 11. So the answer is negative 6 over 11. For part C, we can really simplify the radicand, take the square root of 18 or take the square root of 32, because 18 and 32 are not perfect squares. But what we can do is to simplify the fraction. So for example, 18 and 32, they have a common factor of 2. So you can divide 18 by 2 and 32 by 2. So you end up with a square root of 9 and 16. Now we can apply the quotient property of square roots to simplify this problem. So you have square root of 9 is 3, square root of 16 is 4. So the answer is 3/4. For example D, we have a square root of a decimal, and we can convert this to a fraction. For example, 0.64 is actually 64 divided by 100. And from here, you can apply the quotient property of square root to get square root of 64 divided by square root of 100. And that gives me 8 divided by 10. And you can simplify that further to 4 over 5. Of course, you can also think about, is there any common factor that you can divide 64 and 100 by? And they are both divisible by 4. So you can actually get square root of 16 divided by square root of 25 to give you 4 over 5 as the answer. If you have noticed, all the answers we get in these 4 examples are either in fraction form or whole number, and this is what we call rational numbers. So they are numbers that can be expressed as a fraction. Okay, and so all the square root as fractions. So all the square roots are considered rational square roots. Our next example, we're going to look at some irrational square roots. You might want to take some time to copy down the examples and pause the videos and work through them on your own before checking your solution with me. So 2a, you can see that the radicand 75 is not a perfect square, but I can break 75 into 25 times 3. Okay, and you need to break it up into the product of possibly a perfect square, and that's how you can apply the product property of square roots to help you simplify this. So square root of 25 times square root of 3. So you end up with 5 root 3. Now, the number 3 can be simplified further, and if you enter that into the calculator, you get a decimal that is non-repeating and non-terminating. This is what we call an irrational square root. And of course, this number 75, it will be an irrational square root. Now let's go to example B. 2 times square root of 112. So 2 remains there, and then 112 can be broken up into the factors of 16 times 7. And if you apply the product property of square root, you will get square root of 16 times square root of 7. And that gives me 2 times 4 times square root 7. And the value will be 8 square root 7. For our next example in part C, we're looking at a cube root. So we know that 216 can be divided by 2, so give me 108, and I divide it further by 2, I get 54, and if I divide 54 further, I get 2, and then 27. So 216 can be broken into the product of 2 cubed times 3 cubed. So from here, you can see that I can break it up into cube root of 2 cubed times cube root of 3 cubed, and that will give me 2 times 3, and that will be 6. Of course, you can choose to write it as cube root of 8 times cube root of 27, and you will still get the same answers here as 2 times 3. In example part D, you can see that 375, when you divide it by 5, 375 divided by 5, you get 75, and then you can divide that further by 5 to get 25, and divide that further by 5, and you get a remainder, 75 divided by 5 is 15, and then 3. So 375, cube root of 375 can be broken into cube root of 5 cubed, or cube root of 125 times cube root of 3, and so the answer here will be 5 cube root of 3. And this ends our video on evaluating radicals. So watch out for my new videos on radicals, and don't forget to subscribe in the button below. See you. Bye.